Hello, everybody. Welcome to Universal University. I'm joined by.
Doctoria.
And I'm the Kraken. And today on Wielding Nature, we will be talking about Earth's magnetism. So, Doctorio.
Well, I'm attracted to Earth. Have you ever seen Gaia before? Woo-wee.
That's why they call her Mother Earth.
Zoo-wee mama.
Yeah, Earth Day, more like MILF Day, am I right?
That's so true.
Oh, man.
Mother in love with forest.
So, Doctorio, are you familiar with the term pole switching?
You mean like Poland?
No, I mean like geomagnetic.
I am, actually. And that eventually it's going to happen. It's going to destroy all of, it's going to be a big issue because then we won't have, the magnetic shield for a bit. So isn't it like our communication stuff will all get hit by solar radiation when that happens, and it'll be a big no-no.
I don't know about that. I just know that the magnetic pole switches from time to time, and whatever consequences come from that, I'm just more interested in talking about how and why it happens and how we know. So how do you think we know that the poles have switched in the past?
Somebody at one point in history had a compass. He was like, bro, today or yesterday it was pointing south. Today it's pointing north. Or wait, the other way around. They just swapped north and south or something. Either that or they threw magnetic dust into the air and it went towards the North Pole or it went towards the South Pole, and then that changed the next day.
Unfortunately, the poles change very slowly. In fact, so slow that I'm not even sure if humans were around for more than 2 pole switches. But one thing is that the Earth is filled with little pieces of magnet, like iron and titanium are naturally found in the Earth, and they orient themselves towards the poles. And so we've done some digging, and we humans have realized that sometimes the poles, where Santa Claus lives, and then sometimes the poles where the Coca-Cola ads take place.
Aren't those the same?
Aren't there Oh, wait. Are there polar bears in Antarctica?
No, there's no polar bears in
Santa Claus does love his Coke. All his white powder. I mean, red soda.
Yeah, Santa Claus up top, Pepsi Man down bottom. Well, you know this.
But the reason that it's so interesting about having pole switch, besides what you mentioned with the solar radiation shield, is that the magnetism actually influences how solar winds can hit the Earth, which affects weather patterns and climate and all this other juicy information. So, yeah, the Earth is just this gigantic magnet, this giant sphere of magnetism, and a bunch of wacky stuff happens to it.
Yes, it does. I live on it. I'm the wackiest thing on it. Mother Earth ain't seen nothing like me.
I don't understand. Isn't it obvious, Morty? I f***ed a planet.
Now, here's my physics question for you, Kraken, now that you've lectured about a curvaceous Earth for a bit. Let's say I've given you a bunch of copper wire, and you want to create a magnetic field. How would you do that?
I would tightly coil the wires and create a gap in the middle so that it looks like, a slinky, and then run an electric current through it. And then now when I drop my nickel into the tube, it falls slower. I give it a potion of slow falling.
True. True. Curving currents are magnets. That's one of my favorite quotes. It's not necessarily true, but it does induce a magnetic field due to some Faraday law, probably. Faraday was a guy.
Looking at those curvy coils, that induces something else, if you know what I'm talking about. But that's for next episode.
That was Faraday's law.
Thank you, everybody, so much for listening and watching. Oh, man. We will see you next
Those
time.
curvy currents are lowering my resistance.
Yeah, those Faraday goon units.
The voltage between us is increasing the power. Hey, yo. Bye-bye.
Inverse square law. Goodbye.